So the first thing that you want to do whenever you have your burette is you want to get a funnel and put it in the top of the burette. Then, once you have your sodium hydroxide solution, you want to transfer approximately 5 milliliters of that sodium hydroxide solution. Take the glass funnel out, and then invert, rotate, invert, rotate, ultimately so that you're coating the interior of this burette with the sodium hydroxide solution, or with your sodium hydroxide solution. Whenever you're done with that, you can open the valve so that the sodium hydroxide will freely flow out of that piece of glassware. Okay, so my burette is empty out at the moment. Once that's all done, there we go. And close the valve. Okay. The next thing that I'm going to do is take my funnel and put it back at the top of my setup here. Carefully and slowly transfer sodium hydroxide. I had to lift this up because there was a little bit of a vacuum that was produced, so none of my sodium hydroxide actually went in there. Transfer sodium hydroxide. Careful so that I don't add too much. Oh, I added too much. Oh no, but that's fine. Because I've got my waste container right here, and I'm just going to put the waste container at the bottom of my system. Empty a little bit out so that my solution hits the 0 milliliter line. There we go. It's perfect. It's all set. Okay, so now my burette is ready. I've got my sulfuric acid solution, and what I need to do with that is I need to add a small amount of my phenolphthalein indicator solution. All I need to add are 2 to 3 drops, so 1, 2, 3. Okay. No color change was observed in my sulfuric acid solution, which is great because I wouldn't want it to change colors. So now what I'm going to do is I'm going to begin my titration. So I'll adjust this down. My solution is at 0 milliliters, so I'm going to pick this up. Start. Adding base, adding sodium hydroxide. 5 milliliters have been added. I'll stop, swirl a little bit. Do I see anything? I don't see anything. 6 milliliters, nothing. I'm not seeing my color change at all. Oh, I think that it just started to change a little bit. Okay, so I'm going to adjust my camera setup here so that you can get a little bit of a better view of things. Okay. Oh, it's ever so slightly turning purple just as the sodium hydroxide hits the sulfuric acid. I've already added more than 10 milliliters. Spin, spin, spin. Oh, it goes away. I've slowed the burette's flow rate down considerably. Because I don't want to overshoot my solution, or I don't want to go beyond the adding the right amount. Stop, spin, 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 stop. So close, so close. Nope. I'm going one drop at a time. Stopped. Still going. Oh, oh, oh. Oh, it's gone. Okay. So that was as close as I was going to get. Now, the intensity of that solution tells me a little bit about how accurate my results were. I can see that my solution is a pretty robust magenta purplish color. So I definitely went beyond where I wanted to, but I'm just gonna, as a demonstration, I'm letting the sodium hydroxide basically empty out into here. And you can't really tell that much of a difference. So that tells me that I was pretty far off. Just because as I add more and more sodium hydroxide and make the environment more and more basic, well, it's not getting darker. If it were getting darker, that to me would be like, oh, well, you were close. But since it's not getting darker, that means I wasn't really close. Okay, so what you need to do whenever you're looking at this sort of chemical reaction is think about, well, what are my reactants? I had sulfuric acid and I had sodium hydroxide. Those will dissociate into 2 H pluses and 1 SO4 2 minus. Sodium hydroxide will dissociate into 1 Na plus and 1 OH minus. So when you do a double displacement reaction, well, it's a double displacement reaction, but it's really more of a neutralization reaction. So what are the products that come from that neutralization reaction? I hope this is helpful, and ultimately, this is a titration. This is a different sort of titration. It's still an acid-based titration, but we've added an element to that second, or to that acid, sorry. All right, well, have a good one.